Howdy students, this is Geometry, Note 6.2, Properties of Parallelograms with Mrs. Moslick. We're going to just start with, if you have a parallelogram, then there are 6 properties that are true. We're also going to learn that if one of these properties is true of a quadrilateral, then that quadrilateral is a parallelogram. So the first property is going to be the definition. So let's go ahead and just right next to the first one, I'm just going to write definition. And so DEF for definition. And that is, what is a parallelogram? It is a four-sided object, meaning it's a quadrilateral, with two pairs of opposite parallel sides. So that is a parallelogram. Let's write it down. So we have two pairs of opposite parallel sides. You can just use the symbol for parallel. Okay, next property, if you have a parallelogram, then something else that is true is that you have two pairs of opposite congruent sides. So two pairs of opposite congruent sides. If you have a parallelogram, then you also have two pairs of congruent opposite angles. And I'll draw a picture. So I want you to draw a picture for each of these and use words. So two pairs of opposite congruent angles. Okay, those are the two pairs of opposite, two pairs of opposite, two pairs of opposite. What is also true is that if you just see a picture of a quadrilateral with one pair of opposite parallel sides and they're congruent, we'll also note that that is a parallelogram. So we'll say one pair of opposite congruent and parallel sides. Okay, can you think of anything else that you know about a parallelogram? Or when you draw a picture of a parallelogram, what seems to be true? And we talked about this also in the last lesson, 6.1. And what we found out is that not only are opposite angles the same measure, but angles next to each other add to 180. So you could just say x plus y equals 180 degrees, or you can say consecutive angles are supplementary, or they add to 180 supplementary, or they add to 180. This is the easiest notation. Just note that if you are given a situation where consecutive angles are supplementary, you know what consecutive means. That means the angle right after one another. You can't say adjacent, because adjacent means that they share a vertex and a side. And the last property of a parallelogram is about the diagonals. And so let's just draw the diagonals and figure out what is true. Now, are they congruent? No, they're not congruent. One is smaller, one's bigger. But do you see that they bisect each other? So the diagonals bisect each other, or you can say meet at their midpoints. So there are different ways you can say this, or you can say diagonals bisect each other. So if you know you have a quadrilateral that's a parallelogram, all 6 of these properties are true. Moreover, the converse is true. If I see one of these pictures, then for a quadrilateral, and it has one of these sets of properties, then I know that quadrilateral is a parallelogram. That's what you have to know for these notes for 6.2 and 6.3. So we're going to do a lot of repetition in 6.2 and 6.3. Let's go ahead and organize some ideas of quadrilaterals. So we're going to fill out this Venn diagram. So all of this is going to be quadrilaterals. We just talked about parallelograms, and we found out that by the definition, that means that we have one pair, sorry, two pairs of opposite parallel sides. And the definition of a quadrilateral is just any four-sided object. Okay, a parallelogram could specifically be a rectangle. Not all parallelograms are rectangles, but all rectangles are parallelograms. Now, a rectangle is a parallelogram with four right angles. That's the definition of a rectangle. And a rhombus is a type of a parallelogram. All rhombi are parallelograms, and not all parallelograms are rhombi. So, what is a rhombus? It is a parallelogram with four congruent sides. And then a square is a rhombus and a rectangle. So, all squares are rhombi, all squares are rectangles, all squares are parallelograms, but not all parallelograms are squares, not all rhombi are squares, and not all rectangles are squares. Okay, so a picture for a square. So when you're filling out one of these Venn diagrams, please draw a picture that represents the definition. A square has to have all four right angles and four congruent sides. Okay, now we also have trapezoids and kites. Let's talk about trapezoids first. A trapezoid, by definition, is a four-sided object, one pair of parallel sides. Now we also have a specific type of trapezoid inside this circle. I'm going to call it the isosceles trapezoids. So ISOSCELES trapezoid. And an isosceles trapezoid is a specific type of trapezoid where you have two sides that are congruent. So one pair of parallel sides, and then the non-parallel sides are congruent. That would be your isosceles trapezoid. And then lastly, a kite. The definition of a kite is a four-sided object with two pairs of consecutive congruent sides. Remember that word consecutive means right after one another. Okay, so you have to know this Venn diagram. Can you write out with the vocabulary words, and can you draw a picture of each definition? In the future, I'm going to ask you, in addition to this Venn diagram, I want you to add how many properties does each one of these have. Right now, you know that a parallelogram has 6 properties. The 5 qualities in addition to the definition for a parallelogram. And then we're going to fill this in with all the other numbers later on as we progress through this chapter. Okay, we're done with this lesson, but let's review chapter 4 by proving. Now, you've done this proof before, or many of you have, especially geometry honor students. Prove that any point on a perpendicular bisector of a line is equidistant to the segment's endpoints. And so if you're in geometry honors, go ahead and continue with this lesson so that we can review this. If you can, go ahead and do this on your own. Just pause what I'm going over. This is review. If you don't remember, then don't pause and just work this with me. Okay, what we want to prove is that the length of line segment PA equals the length of line segment PB, given that we have a perpendicular bisector of this segment AB. So that means it's bisected this segment and it's perpendicular. So hopefully you can see already that we're going to be using reflexive, and then we'll have a side angle side situation. And then by CP/CTC, corresponding parts are congruent. So let's go ahead and go through these steps. The first step is PM segment is the perpendicular bisector of line segments AB. That's the given. Now let's go one word at a time. Whenever you see perpendicular, you should have 3 steps in your proof in this class. So definition of perpendicular means that the angles are 90-degree measures. So measure of angle AMP is 90, and the measure of angle BMP is 90. Do you remember what's next? Yes, you're right. Transitive is next. We have 2 of these. Each have a 90-degree angle. Since they both equal 90 degrees, I'm going to just highlight those so you can see, oh yeah, this is a transitivity step. So I'm just going to write down transitive or transitive property or transitivity means that both of those measures, measure of angle AMP and measure of angle BMP, are equal to each other since they both are 90. And then we'll use the definition of congruence. Angle AMP is congruent to angle BMP by definition of congruence. Okay, so we are done with the perpendicular. Now let's go with definition of segment bisector. So definition of segment. So are we bisecting a segment or an angle? We're bisecting a segment. So segment bisector. So in our statement, we're going to be talking about segments. So segment AM is congruent to segment BM. And then the last thing we have to do is talk about this reflexive. So PM is congruent to itself because of reflexive. So reflexive, and that was our PM is congruent to PM. PM is congruent to PM. Now I'm just going to pause and just remind you that when you are doing a proof like this, and we are given a few things in the given, note that your order does not have to be exactly the same as mine. For instance, I use the definition of perpendicular and those 3 steps right away. I then use definition of segment bisector, and then I used reflexive. Oopsies, I want to use the pink. Is that going to change? Going to just take a while. So these 3 sets of steps, oh, that didn't work well. But these 3 sets of steps could be in any order. So it didn't matter if I used this first or this first or this first. So these 3 could be in any order. Okay, now we are going to say that the 2 triangles are congruent by side angle side. So AMP is congruent to triangle AMP is congruent to triangle BMP by side angle side. Then by CPCTC, corresponding parts of congruent triangles are congruent. So then we'll say that those 2 segments, AP and BP, are congruent. So AP, oh, do I want to use that? I want PA first. So the order does matter if they specifically say they want PA. So PA segment is congruent to PB segment. And then by definition of congruence, the line segment lengths equal each other. Definition of congruence. Now, CPCTC, we must write it out in words. So corresponding parts of congruent triangles are congruent. Hopefully you guys are getting more comfortable with this. If not, practice more. If you're still confused, get help. It should be pretty easy at this point. Have a good time. If you have any questions, ask around and practice. Have a great day. Toodle-doo.